What about here?
Yep. If
What
you
about
move
here?
like move a couple inches this way. All right, stop.
What about this?
Yeah, you're good. You should move back the other way. That was better. Sorry. You're fine. You're good.
I just want to be comfortable reading these things.
Oh.
Kind of. Like, it's okay. So,
You're
I
good.
look okay there?
Mm-hmm.
Okay. See, now I can't pause it. Okay, by far the one that came up the most was if you're 18, you can vote. You are 17, therefore you cannot vote, which is invalid. Why is it invalid? Well, let's go through putting this in a form that makes us ignore the content and still get the logic right, because we always check the logic first. So that's for you are 18, let's call that A. So premise 1, sorry. If you are A, then you can vote. If you are A, then you can vote. You are B, therefore you cannot vote. Okay. Let's look at the logic of this. If you are A, then you can vote. Doesn't say anything about what happens if you're not A. In terms of logic, this could also say, if you are A and if you are not A, you can vote. But all it says is, if you are A, you can vote. So that's all we know here. You are B, something different than A, therefore you cannot vote. The reason why it's invalid is because it's attempting to make an argument that looks like a way one argument, but it's not successful. Why isn't it successful? Well, we know how to check for that. We just check and see if we can find a way in which premise 1 is true, premise 2 is true, but the conclusion is false. Why do we know that's a way of figuring out that it's invalid? Because of truth preservation, and because we don't want things that are called logically valid to go from truths to falsehoods. Okay, so if we can find a situation in which it does go from truths to falsehood, then we know it's invalid. Now, I know that sounds probably head spinning to some of you. The best thing I can say is rewind and play again because it's true. It's a little bit convoluted. It's like taking 2 steps back to get somewhere else. But the reason is we check for validity. This is just one way to check. If you are A, then you can vote. You are B, you cannot vote. If we can find a situation, an imaginary situation, in which this is true, and this is false, then we know it fails the test of truth preservation, which is what the logically valid thing is all about. So that's why it's invalid if we can find a TTF structure. So let's think. If you are A, then you can vote. Let's just put some number in there. If you are 20, then you can vote. Let's put some other number in here because it doesn't matter. You are 18. If you are 20, then you can vote. You are 18, therefore you cannot vote. Well, given what we know here, all we know for sure, for certain, if we hold this one true, is if you are 18, then you can vote. The only other thing we know is you are 18. We're going to hold that true too. But you could still vote. We can think of a situation in which you might still be able to vote, in which this is true and this is true, but you can still vote. Maybe it's a college election and somebody's just trying to make a logical point. And they say, if you are 20, you can vote. And they just want to see how good your logic is. And then they give you, but you're 18. Therefore, you cannot vote. That might be a case, right? And you say, no, you're just joshing me. I can vote. I'm 18, but I can vote. I attend this school, therefore I can vote. So the idea is, what that scenario is called a counterexample. And that's just one way to prove the logic is flawed in an argument. And yeah, I think I'll